In this section, we'll be discussing discrete variables and the binomial distribution. So recall, a random variable is a variable that is subject to change due to chance and events. It's denoted with a capital letter. Typically, we use a capital X for our random variable, but if we were talking about multiple random variables in the same question, we could use additional capital letters. Discrete data is data that you can count. So it's data that does not take on all of the small little fractions and decimals of values. Usually it ends up being whole numbers, but just data that can be counted in some way. So then a discrete random variable is a variable whose possible values are a list of distinct values. We can create a discrete probability density function then, which describes the relative likelihood for a discrete random variable to take on a given value. Usually these are given in a chart or in a graph, or both. So recall, for a probability density function, for any probability density function, all probabilities in that have to fall between 0 and 1, and the sum of all the probabilities is 1. So that applies here as well. We are now just getting very specific. The type of probability density function we're talking about is a discrete one. So here's our first example. It says, you flip a coin 3 times in a row and you record the number of heads. The number of heads that you see is the discrete random variable capital X. List all of the possible values that X can have. These are denoted with lowercase x's. Okay, so let's see. We're getting the number of heads that you see. So what can all of these small x values then be? I could see 0 heads after 3 flips. I could see 1 head or 2 heads, or all 3 of them could be heads, and then that would be it. So that is just a list of the outcomes that we could see for this random variable. To actually create a discrete probability density function for the number of heads you can see when you flip a coin 3 times, you need to find the probabilities of each one of these. So we already know the different values that X can take on. It could be 0, 1, 2, or 3 heads observed. But now what we need are the probability of seeing 0 heads, the probability of seeing 1 head. And in order to do that, we need to have the entire sample space listed. So I'm going to call this capital S for the sample space here. What we could see when we flip a coin 3 times. So we might see heads, heads, heads. We could also see, we could see heads, heads, tails, or heads, tails, heads, or tails, heads, heads. That would be all the different ways we could still see 2 heads but 1 tail. Then we could see, what if there is only 1 head? That could look like heads, tails, tails. Oops. Or it could look like tails, heads, tails. Or it could look like tails, tails, heads. And then the last thing that could happen is we could get all tails. So my sample space has 8 elements in it, 8 outcomes, and now I can finally find the probabilities. So out of the 8, how many of them show 0 heads? That would be just this last one, so 1 out of 8, or 1/8. How many of these outcomes show only 1 head? That would be here, here, and here. So 3/8 probability of flipping 1 head. There's also a 1, 2, 3/8 probability of flipping 2 heads, and a 1/8 probability of flipping all 3 heads. And notice if we add all of those together, if we add 1/8 plus 3/8 plus 3/8 plus 1/8, we get 8/8 or 1. So this is the probability density function Notice that all of the probabilities listed are numbers between 0 and 1. 1/8 and 3/8 are both values between 0 and 1. And when we add them all together, we get 1. So this hits the 2 criteria. Once you have a probability density function created, you can answer different questions. So it says, what is the probability that the random variable x will equal 2? Well, I can go over to my chart, and I can see that the probability of getting a 2 is 3/8. So the chart is one way that you may see your probability density functions, and then the other way is in a graph. So here's what the graph looks like. We have the random variable x across what would be the x-axis. So the values of 0, 1, 2, and 3 are listed there. And then up the y-axis, we have the probability of each of these. And we have, notice that 0 goes up to the 1/8 mark, 1 goes up to the 3/8 mark, 2 also to the 3/8 mark, and 3 to the 1/8 mark. And also notice that these x values are discrete. There's no way to roll any decimal or fractional amount of heads. There's no possible way to roll 1.5 heads, right? So there's nothing marked on the x-axis between 1 and 2. That's why they're just lines that go straight up, because there's no way to get any value in between 0, 1, 2, or 3. That's just it. That is how we show, or that is how visually, very quickly, we can tell that this is indeed a discrete probability functions.